So now we're going to take a look at what happens if we add together the values of an arithmetic sequence. And what that means is that we get an arithmetic series. So this is going to be a little bit different than what we did before. Again, we're going to be adding up the terms of the arithmetic sequence. So we want to remember that a partial sum of a sequence is adding together the however many values you need to. So we're going to consider a partial sum here of a sub 1 through a sub n, adding them together. Now what I'm going to do is let's think about the fact that s sub 1 is a sub 1 and s sub 2 would be a sub 1 plus a sub 2. But we want to think about the fact that because this is an arithmetic sequence that we're adding the terms together of, a sub 2 is just a sub 1 plus d. So that is 2a sub 1 plus d. Okay. Now s sub 3, the partial sum of the first three terms of this arithmetic sequence, is going to take a sub 1 plus a sub 2, which we have here from the last one, and then a sub 3 is going to be a sub 1 plus, as we've already done, a difference plus another difference, so plus d plus d. So we end up with 3a sub 1 plus 3d. Okay, now you might be thinking you see a pattern, but maybe not quite yet, so we'll do another one here. So s sub 4 is going to be really s sub 3 plus a 4. So we're going to take what we just got, 3a sub 1 plus 3d, and then we're going to add the fourth term. But as we learned from our last page, the fourth term is a sub 1 plus 3d, three differences. And so this gives us, you can see 4a sub 1 plus 6d. So whatever pattern you might have thought you saw might not be there anymore. That's all right. We'll talk about it in a second. So one thing you might notice, however, is the a sub 1 part. So just to give you that, you see that s sub 1 is a sub 1, s sub 2 has 2a sub 1, s sub 3 has 3a sub 1, s sub 4 has 4a sub 1. So you won't be surprised to find out that s sub 5 has 5a sub 1. And then you might be thinking, what is this pattern for the coefficient of d? We have no d in the first one, and then we have d, then we have 3d, then we have 6d. You might be like, maybe I see it, maybe I don't. I'm going to tell you the next one is 10d. So if you're like, I didn't see that, that's okay. So here we have, thinking about s sub n for an arithmetic sequence, the sum, the partial sum of the terms. You can probably see that whatever your n is, that's going to be the same coefficient in front of the a sub 1. So n times a sub 1. So for that coefficient, the number that's in front of the d, you see that we have technically 0, because there's no value for d for s sub 1, and then we have 1, 3, 6, 10. So those are the first ones that we have. So in thinking about that, what we're seeing here is actually this this series, and I'll explain it in a second here, but I wouldn't expect anyone to have this off the top of their head. So like this, and then n minus 1, so adding that, and then times d. So what this is, this series here, notice that when n is 1, you actually just get 1 minus 1, which is 0. So that's the first one. When n is 2, you get the 2 minus 1 is 1. So that's the first term. When s is 3, you get 3 minus 1, which is 2, so that's 1 plus 2. When n is 4, you get 4 minus 1, which is 3, so that's 1 plus 2 plus 3, which is the 6. And then the next one you'd be adding 4, and then the next one we'd add 5. So that's the idea there. And if you think, well, that looks kind of long, I don't like it, that's all right. You can actually sum this series right here. So this can actually be found. It's proved by something called mathematical induction, but the sum of that in a shortened way is n times n minus 1 over 2. So let me write that. So n minus 1 over 2 is what I need. Minus 1 over 2, and then times d. Okay, now if you're thinking, that still looks kind of long, sure. You might notice what we have up here. This is actually what I'm getting towards, and there's a couple different ways to write that. So, realize that. We have the way that I wrote it right here. You can also think about factoring out an n over 2. If you factor out an n over 2, you'll end up with 2a sub 1 for this first piece. If I factor out an n over 2, I need to add a 2 up top. And if I do that in the second piece, I have n minus 1 over 2 times d. Actually, my 2 has been factored out, so I don't need that. It's just, like I said, different ways to write this. So just know a couple different ways. So just an n minus 1 times d. And then, as you can see, there is actually another way to write it. And some might be more helpful than others. But what I want you to remember is when we think about what we have here, where can I think about that? Let's think. So this piece right here in the parentheses, this whole piece right here in the parentheses, can be seen in a couple different ways, but it is a1 plus a1. So we have the n minus 1 times d. You want to remember, though, that this is what we found from the last page. It's just a sub n. And so that's why we also can write this as a sub 1 plus a sub n. So that's just another way to write it. So depending on what you're being given, and we'll see that in the next couple of examples, you may find that using one or the other of these formulas is more helpful. So let's take a look. So find the sum of the first 25 terms of the arithmetic sequence where a sub 1 equals 3 and d equals 4. So if you take a look up and you look at your text box, you'll see that your job is to find the sum of the first 25 terms, so S25. If you look at your options, one of them requires n, which you have, and a sub 1, which you have, and d, which you have. The second option in that text box, in the middle of the page, wants a sub 1 and a sub n, but you don't know a sub n, and so that would be a lot harder to use. So instead, you could find a sub n and then do it, but you could also just do it in one shot. So we're going to use this partial sum. S sub n equals n over 2 times 2a sub 1 plus n minus 1 times d. Again, we're finding S sub 25. We know that our n here, this is what we're trying to find, it does tell us that n equals 25. So we have 25 over 2. Then we have 2 times a sub 1 plus n minus 1, so 25 minus 1, times d, which we know is 4. So as you can see, we just have a bunch of numbers here that we need to simplify. If you want, you're welcome to pause, see if you can simplify everything there together. So we have 6 plus 24 times 4. And let's think about my spacing. 25 over 2 times, so 24 times 4 is 96. 96 plus 6 is 102. And you can see that that gives us, we can actually simplify here to have 25 times 51. And 25 times 51 is 1275. So that's the summation of the first 25 terms of the arithmetic sequence. So you can see that a sub 1 is 3, a sub 2 is 7. So I'm just adding 4. A sub 3 is 11. A sub 4 is 15. And so on and so forth. And then if you were to add all those values together, you're going to get the 1275. So they're going to get fairly big fairly quick, and you're adding them, adding them, adding them. So our answer here, though, again, is the sum, the 1275. So our last example here is, suppose the first term of an arithmetic sequence is -2. So we already know a sub 1 equals -2. And the last is 33. So we know that there is some part, of this sequence where the last term is 33. Well, we don't know the n, but we do know the sum. So we know the sum of those values is 1643. Our job, find the difference and find our n. All right, so we gotta, we can think about these equations that we have, formulas, I should say. And we notice that we do have in our text box, middle of page 4, we have a second one, which is S sub n equals n over 2 a sub 1 plus a sub n. So you can see that we have a sub 1, we have a sub n, and we also have s sub n. So because of that, we can now find n. So we'll put it here, find n. So we can put in these values over here, find n. If you want, you can pause and go ahead and see if you can do that. A sub 1, a sub n, and then we just solve. So we will have 31. Okay. I can multiply both sides. That's 3286 equals 31 times n. And n, which does need to be a whole number, it's a subset of the natural numbers, is 106. So now we know n is 106. So we know that it's the 106th term that is in fact 33. So the last one is 33, the last term is the 106th term. Now that we have this, we can find the difference. Now finding d might be easier than you think, depending on how hard you think it is. But we remember that a sub n for any arithmetic sequence, a sub n is just a sub 1 plus n minus 1 times d. So we have all this information that we need, and then we'll solve it for d. So we have a sub n, that's the 33, it's the last term. And we have our a sub 1, which is -2. We just found our n, 106, so we have 106 minus 1, which is 105, times d. I'm just doing this due to space. So we get 35 over 105 times d, and then we divide, and we get 35 divided by 105, which you might think is quite the fraction, but actually 35 goes into 105 3 times. So we get a difference of 1/3. And we've now found our n, which we were asked for, and our d, which we were asked for. And that is section 12.2.